So before we get started, Venkat made reference to a story that I'm not sure all of you are aware. The very first Riga Dev Day, they invited me out to come do the keynote, and the night before the conference, I slipped on some ice and broke my shoulder. And the first that Dmitry or Andrei knew about it was when they were gathering the speakers in the hotel lobby for the speaker dinner, and I'm surrounded by emergency personnel. And Dmitry actually, at one point, drove me to a private clinic that was in the same building where he worked. And they diagnosed that I had fallen so hard, I had fractured, basically splintered off a piece of the bone. And they took me to a clinic and they said, "Oh, we'll do surgery for you." And I said, "No, we're not." And they said, "Well, why?" And I said, "Because I have keynote tomorrow morning." And the doctor's like, "Okay, fine. We'll keep you overnight and release you in the morning." And I said, "Well, what time?" And they said, 10, 11, noon, what difference does it make? And I said, "I have keynote in the morning." And at this point, the doctor's looking at me like, "You stupid fucking American, we're trying to help you." So they brought me back to the hotel. The hotel staff said, "Is there anything we can do for you?" And I said, "Well, I'm not going to sleep very well. Do you have any pillows?" And they said, "Oh yeah, not a problem." They came up, they brought a full luggage cart filled with pillows. I had enough pillows to make a fort. So I did. I made a pillow fort on my bed so that I could sleep sitting up like it was Game of Thrones or something. It was awesome, aside from the fact that my shoulder is really, really hurting. So the next day, I decided the night before that it was going to be really hard because I can't move my shoulder at all. It hurts. So getting dressed is going to be tricky. So I'm going to take my shower now and get dressed in the morning, etc. And that's when I discovered something really, really important. It actually takes two shoulders to button your pants. So I'm thinking this is going to be awkward because I'm doing the keynote on opioids and my pants will fall down in the middle of the keynote. This is not going to go so well. So as I'm thinking about this, once we get to the venue, one of the conference staff comes up to me and says, "Ted, this is so great that you're doing the keynote. Is there anything we can do for you before you get started?" And I said, Needless to say, the keynote went off spectacularly. But when Dmitry emailed me last year to say, "Would you like to come out for Riga Dev Days?" I'm like, He's like, "It's okay. We moved the conference to May just for you. No more ice." I said, "Okay, I'll be happy to come back." So here I am. And if you're looking at the screen, you're probably wondering, what the hell is polytechnical careering? Because this is not a term we hear very often. When I use the term polytechnical, I mean that to be a little bit more than just polyglot. For those of you who aren't familiar with the English term, a polyglot is one that speaks multiple languages. By the way, does anybody know what we call somebody who only speaks one language? An American, you're absolutely right. But there's also more than just language at work here. There's also different ways to store things, which I looked up the Latin. It's actually polypraeclusio. And then there's actually the notion of multiple platforms, which I sort of liberally translated as foundation, which is polycrepido, which means that, yes, if you know multiple platforms, you're obviously producing crep on all of them. That's the best joke in the lot, guys. If you're not going to laugh at that, it's going to be a very long keynote. Okay? So you're all three of these things ideally. You're familiar with multiple database storage technologies, which is to say the relational database plus all the various flavors of NoSQL that we see coming around. If you're familiar with multiple platforms, Java, .NET, JavaScript, possibly Python or Ruby, et cetera, you're familiar with multiple platforms. All of this collectively is what makes you polytechnical. When you are polytechnical, there are a number of advantages that come along for the ride. For example, you begin to understand that there is no one best technology. You understand that, for the most part, any project you throw at me, I could do in Java, or I could do it in .NET, or I could do it in JavaScript, or I could do it in Haskell, or I could do it in, heck, I could probably even do it in COBOL. Just not Perl, because Perl is terrible. No Perl, right? We're just going to pretend Perl never happened. You don't believe that there's just one answer for any particular problem that comes up. There may be constraints. There may be scenarios where you say, well, we need to deploy this into an environment that has only .NET code running inside of it, and we need to make sure that we stay compatible with whatever other monitoring and management tools we have. Okay, that will probably point towards using a .NET solution as the best answer for the given constraints. But if we put it into a different set of constraints, same project, but now it needs to run on Linux servers, well, yeah, that's probably going to be a good Java solution or a good JavaScript solution. Or hell, today we just put everything into Docker containers and ship it wherever. So yeah, let's just do everything in Docker the end, right? That actually was supposed to be a joke. You guys awake out there? Yeah, no, there's somebody in the back who's like, Docker, he made fun of Docker. Urgh. The whole point of Polytechnical is the idea that we can mix and match. We can bring the best of whatever particular tool to the fore. We can basically, you'll have to pardon this for a second. I realize for some of you, you're old enough to remember Latvian history a little bit more than the rest, but I'm going to paraphrase Karl Marx and say, from each language according to its abilities, to each project according to its needs. That's actually what Marx intended to say. A little got lost in translation along the way, and then Stalin and whatever. Why? Why would you want to do this? I mean, if you think about it, when I don't stick to one stack, things get complicated. I mean, for starters, I have to think about how much do the developers on my team need to know? If I say that we're going to mix C# and Java and JavaScript, et cetera, that means that you have to know all of those tools. You have to know all of those languages. You have to know all of the IDE tools and command line tools. I mean, even if we say, I'm going to do a straight JavaScript project, you already know that that's not really true, because you're going to have to know HTML, and you're going to have to know CSS, and you're probably going to have to know SQL. Or if you're using a NoSQL, you're going to have to know whatever query API they provide. It's never as easy as knowing just one language. You might have to know some XML for configuration purposes, or some YAML. You might have to know whatever other configuration files are required based on whatever DevOps infrastructure you use, et cetera. Why would I add to the list of things that people need to know in order to get this project out the door? And that doesn't even begin to talk about the direct interoperability issues. If I have .NET code and I wanted to call Java code, how do I make that happen? In the 2000 timeframe, we said, web services, this is how we do it. You just sit down and you write a WSDL schema, and then you run it through a tool, and it will generate a bunch of code. And yeah, your .NET object's going to have to turn into XML, and then that's going to have to turn into Java. And yeah, it turns out that those two type systems aren't exactly aligned. And by the way, XML schema has 9 different ways to represent a date. This is easy. Why on earth would you subject yourself to this level of complexity in any real-world scenario? There are a couple of scenarios that I want you to think about in terms of projects that may actually serve to benefit. For example, how many of you work on a project, show of hands, where the business changes their mind? Wow, there's a lot of hands up there. Haven't you guys trained your users yet? You get to make one decision, and that's it. And after that, it's a whole new No, seriously, Business changes their mind, in some cases because they have no choice. If you work for a company, for example, as I do at the moment, that deals with US mortgages, literally loaning people money in order to buy homes, there's all kinds of issues that come up, legal ramifications, they're changing the law, there's various programs that are being offered, etc. This is not the people, the users at the company saying we need to make these changes. This is literally coming from the federal government, the state governments, various cities, the various agencies, Fannie Mae, Freddie Mac, et cetera, that provide loans. We don't have any control over that. So yeah, the logic changes on a regular basis. And every time it changes, we have to pull developers into a room and say, now, let me sit here and try to explain the entirety of home mortgage to you. And Venkat's not even looking at me as I do that. Or you, or you, or you. How many of you know your business domain better than the people working there? Show of hands. I don't mean you think you know the domain better. I mean you actually know it better. Still, one guy's like, oh yeah, I got it. That's me. Yep. Turns out my domain is playing World of Warcraft because that's what I do, but when you run into these situations, trying to get the domain experts to explain to you, it's often like that game we play as children called Telephone. You ever seen this one? It's a fun game to play. You get like 5 or 10 people lined up in a row, and you whisper a message into one person's ear. Vote for Venkat for best speaker. Yeah, I got your back, buddy. And then they whisper it to the next person, and 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 they whisper it to the next person. And when it finally gets to the last person, he stands up and says, and the message is no collusion. And you're like, what? How did we get from A to B? Well, we lose a little bit in translation every time it goes through somebody's head. You've been on projects like this where the domain experts are sitting down and trying to explain stuff to you, and you're faithfully taking notes and you're still getting it wrong. And they won't point that out until you actually go to production. Thank you very much. Yeah. Sometimes the requirements don't fit a particular paradigm. You're standing there and you're like, oh yeah, we are object-oriented developers. We love objects. Everything is an object. And then somebody says, yeah, by the way, here's this workflow process you have to go through in order to get this document from a started state to an ended state. How does inheritance help you with that? Doesn't. You end up having to create these really, really tortured object diagrams, trying to figure out how exactly do we model processes as objects and how do we use inheritance. And holy crap, we end up with a pile of code, and it's brittle and it's hard to understand. And anybody who wasn't there when we created it will look at it and go, what were you smoking? What if, bear with me here for a second, what if we could actually put something in front of the domain experts to say, here, you do it? Wouldn't that be fun? Seriously, if the logic changes, you do it. Let's put something in front of you that you can understand. You don't have to be a programmer, you just have to be logical, which I know users, logic, don't always meet. But let's give them the power. Let's use that dime store management word, empowerment. Let's give them the ability to make the necessary changes that they need to make so that I don't have to be in the room and that I don't have to run a full-blown project to put a couple of logic changes, particularly if they're small changes. The state of Delaware has now decided that when they loan mortgage money through Fannie Mae, that in fact the interest rate will be a 0.5 point over prime instead of 3/4 point. Okay, that's literally one constant that we change inside some code. Does that really require me to do that? Or can I set up a scripting engine that will allow people to change those potentially on the fly in production if we really want. We often don't want, but if we can have them do it in test, make sure everything works, and then release it straight to production, it's not a terrible idea. By the way, you know who does this a lot? Game companies. Where's my World of Warcraft dude a few minutes ago? Yeah. World of Warcraft is actually written entirely in Lua. It's a scripting engine that interoperates very easily with C and C++. It's not the only one that does that, but that's what allows for a tremendous amount of flexibility and modification. In some cases, the problems are really complicated. Everybody familiar with Sudoku, right? You got that 9x9 grid that's broken up into 3 squares like a tic-tac-toe board, and each grid is supposed to have the numbers 1 through 9 in it exactly once, and it can't have the same number going down, and it can't have the same number going across, and all the numbers have to be unique within each little subgrid. Ever tried to code that? Ever tried to create a Sudoku solver? It's actually a pretty challenging problem in Java or C# or C++. Turns out to be about 15 lines of Prolog, which is a logic language specifically designed to deal with these kinds of constrained logic problems. And in some cases, we want those domain experts to be able to do things, but we don't necessarily want to give them a full-fledged Turing-complete language, because giving people who have no technical background the ability to write code, well, we tried that once. We called it Visual Basic. We gave it to managers, and we kind of know how that all turned out. So let's create a specific tool. Let's create a domain-specific language that is tightly tied to the domain that these people are in, allows them to express everything they need to express, but does so under a very carefully controlled sandbox. And in some cases, as I said, if the requirements don't fit a particular paradigm, we're looking at that workflow scenario. Well, what is workflow? Workflow is made up of a series of actions that we compose together in a variety of ways. Now, if you've listened to Venkat, or if you've listened to some of the other speakers here, you've probably heard reference to the notion of functional programming and the notion of being able to compose functions together to create a larger function. There seems to be a parallel there, right? Yeah, there's a lot of similarity to being able to do that kind of wiring up. In some cases, you have a team that is not all rock stars or ninjas, or what is the preferred term today? Full stack developer, right? Basically those people that know everything and want to be paid like 50 cents per hour. Right? I don't know what we're calling them. What's usually the case is you have a team that's made up of a couple of seniors, a couple of mid-range, a couple of juniors. Because it turns out there's tons of junior developers out there begging for a chance. And mid-range folks are basically juniors that have had a couple of years behind them, but finding those senior full-stack developers, that's hard. There's a reason why your recruiting department is just pulling its hair out in chunks, is there's not a lot of them. So maybe the right answer is not to continue to try to find full stack senior developers. Maybe the answer is to embrace the idea that your team is going to be made up of a mix of skills. Maybe we leverage various languages and tools in such a way that the seniors are working in a very powerful language like Clojure or Scala or F#. Maybe TypeScript, and the mid-range are building out the applications using your JavaScript, your React, your Angular, etc. And maybe the juniors are contributing by writing HTML and CSS while they apprentice to the mid-range and the seniors until they start moving up the skill ladder. Maybe. One of the frequent responses, complaints, questions I will get after this keynote. Dude, that all sounds great, but it would never work at my company. You just can't bring this collection of people and technology and just throw them together into a big pot and expect stuff to work. It just can't work that way. Maybe not at your company, but Barack Obama had a different experience. When Barack Obama was running for office, they threw together a collection of volunteers. And I mean this seriously in the spirit of volunteerism. They were not paid, and they literally turned nobody away. If you had any sort of technical skill whatsoever and you wished to volunteer for the Obama campaign, they took you in. They built a system that could process 4 gigabytes a second, 10,000 requests a second, running on 2,000 nodes with 3 data centers, 180 terabytes of data, and 8.5 billion requests in total. Design, deploy, dismantle in just under 2 years to elect a president. Don't tell me it can't be done. You may not know how to do it. That's a fair complaint. But don't tell me it cannot be done. So how do we do it? Well, I want to dive into some code here for a little bit, just to talk a little bit about the benefits of this polytechnical thing. How many people in the room know Haskell? One brave soul and a couple of wishy-washy. That's fine. That's fine. We're going to learn a little Haskell while we're here. First of all, this is a list. This is a list of numbers, specifically 3 numbers, 1, 2, and 3. It's an immutable list. Everybody with me? Yeah? Cool. Now, I frequently want to do things with the list, such as, for example, I want to peel off the first part of the list, right? Because one of the things we do in functional languages is we peel off the head of a list, and then we keep the rest of the list, and we keep peeling off the head of the list until there's no more list left to process. And this is part of the reason why functional languages like to recurse so much. So here we peel off the head of the list by calling the Haskell function head, which now means head of list will hold the value 1. Now we have a couple of other similar kinds of methods. Last says give me the last element of the list. And tail says give me whatever is left in the list except the head, which means tail will return a list. As you can see there, it's 2 and 3. And I can take, which is to say I want to remove the first, in this case, 2 elements of that list and just throw them away, right? Or in this particular case, since I capture the results, I'm grabbing the first 2 elements of that list, which is 1 and 2. Very simple list manipulation. You all still with me? Cool. Now, one of the interesting things that Haskell lets me do is do ranges. So here is a way to create a list that stretches from 1 to 100 inclusive. So that if I look at the list, it will be 1, 2, 3, 4, blah, 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 all the way up to 100. And I can even ask Haskell to infer some patterns. So here, for example, I'm saying I want a list of 2 and 4 and then up to 100. And it looks at the difference between 2 and 4 and says, you want the even numbers. Cool, I can do that. So that will give us the even numbers through the list. Now, when I want to process this list, we can use what's called a comprehension. And in this particular case, what I'm saying is I want to take the range of numbers from 1 to 10, and I want to put that into a local variable x. Well, technically, it's not a variable because Haskell doesn't like mutability. It's a local value. And so that x will be returned, and well, see the brackets around it. That means we're going to get basically another list. Now, in the second one, what we do is we take that list of 1 to 10, and this time on the left side of the vertical bar, we multiply x by itself. So this will take the list of 1 through 10 and produce a list of squares, 1, 4, 9, 16, 25, et cetera, et cetera. If you want to do FizzBuzz, by the way, classic interview question, right? FizzBuzz says, let me take the numbers from 1 through 10, 1 through 50, whatever. And if the number is evenly divisible by 3, print fizz. If the number is evenly divisible by 5, print buzz. If the number is evenly divisible by 3 and 5, print FizzBuzz. Otherwise, don't do anything at all. And here, actually, I modified it slightly to be 3 and 5, but also 4, because just to change it up a little bit. And notice that that if statement is on the left side of that vertical pipe, which means we're going to take 1 through 25, put it into X, and then run X through this if code, which will yield a value, which will mean we get basically an array of strings back. You still with me? Lots of languages have this functionality. Scala's got it, Python's got it. Python refers to it as generators sometimes, etc. But basically, this is kind of inverting the traditional for each on a collection, so that instead of calling collection.forEach, here we're basically saying here's the body of what we do, and then down below on the right-hand side of the bar is how we want to go through the list. In this case, just 1 through 25, each element goes into X, the end. Yeah? Okay. Now, Haskell also has this interesting concept called an infinite stream, or an infinite list. In this particular case, what I'm saying is that that list forever literally will never end. Do not call print on this list, because it will never terminate. Now, if you're a Java developer, if you're a C# developer, if you're a C++ developer, you're looking at this code and thinking, how the hell? Because in those languages, when I have a list, all of the elements are in memory. And when we iterate across the list, what we're doing is we're simply moving from the first cell to the second cell to the third cell and so on. How do I have an infinite number of numbers in memory? In finite memory? By definition, this could not happen. Besides which, what good is it? I mean, seriously, you've got a collection of numbers, you've got a list of numbers that will never terminate. What do you do with this? I mean, aside from calculating the US budget ceiling, no? Yeah, all right, fine. It killed in DC, let me tell you. Here I have this other function called cycle, which says, give me a list, and I will infinitely cycle through the list. So in this case, it's a list of one element. And so when I want to take 3 out of that list, it will come back with love, love, love 3 times, which I then go ahead and print. Haskell's got some strange concepts. Why would this be of any use to anybody? I mean, because infinite lists, why would you use this? Got to be some reason. Haskell refers to these as streams, by the way, which if you were in Venkat's keynote, should start triggering some flags in the back of your brain, because pretty sure he used the same word at one point when he was up here writing some Java code. Which brings up a question. Java collections produce an iterator to allow us to walk through the collection. C# works exactly the same way. They call them enumerators rather than iterators, but it's the exact same concept. You walk up to the collection and you say, hey, are you iterable in Java, or are you enumerable in .NET? IEnumerable to be precise. And if so, give me an iterator/enumerator and let me use that to walk through the collection of objects. Why do I need the collection? The collection is just basically where we get the iterator or the enumerator. Do I really need the collection to walk through a collection? Here, for example, is an iterator in Java that will go ahead and produce an infinite list. This thing will continue to produce even numbers until forever. And the empty no-op remove method is actually perfectly legal. It's actually how a lot of iterators behave. They will not let you modify the underlying collection, which, since we don't have a collection, makes total sense. You notice all I'm doing here is I'm just basically double incrementing that count. And at some point it will roll over, but that's okay. I didn't say it was even numbers until infinity. I just said I'm always going to give you even numbers. And then to use it, well, yeah, if I do this, we're just going to keep going on infinitely. That's probably not a great idea. But what if it's a file? Files are not an infinite list unless you're tailing a server log, right? Because server logs go on forever, especially because the server, as long as the server remains alive, it will continue to write to that file. So you want to keep reading as long as there's more data to be read. You want to keep reading that file, assuming that just because we've pulled the last element so far, there's still more to come. We actually want to think of it as an infinite list. So this is a very simple file reader, right? I'm just going to iterate over the file, and you'll notice that my file iterator doesn't actually do the buffered reader.close like it's supposed to. But when this thing goes out of scope, it'll be released. Garbage collection will catch it eventually. If you really care, yeah, you can put the try close logic in there, but that just makes more code than I can fit on the slide. And here is set iterator. I just keep reading lines until I hit null, and then I'll assume I'm done. And again, if the file is being constantly written to, then the Java I/O library will basically block when you're trying to read the next line until it actually gets to a carriage return, and then it will deliver that line and you can move forward. This infinite list thing actually may be useful after all. And so here, this is code where I'm going to walk through whatever that file is, which in this case is this exact source code. You start going down this path. You started out in Haskell learning about infinite lists, and you said, I don't get it. But then Java 8 introduced streams, and you said, wait a minute, I remember reading about streams in Haskell, and sure enough, as Venkat pointed out in the morning, part of the reason they pulled the various functional methods off of the collection classes and put it onto stream so that stream could be a separate concept, so that stream doesn't have to be finite. And if you understand Haskell streams, then you understand Java 8 streams. And now we definitely have something that is directly applicable to your day job. But wait, there's more. Because when you start thinking about infinite streams, and you say, yeah, there's no such thing as an infinite stream, that's not true. Time is an infinite stream. At least we hope so. Granted, the current American president may put a halt to all of that, but for the rest of us, time is an infinite stream. It continues to go. It continues. If we want to process something every second, there is literally no end to time. Server might crash, but that's not the fault of our code. We want to keep processing to the end of time. Now, one of the other interesting things about time is time produces users, and users produce events. Is there ever a finite limit to the number of mouse clicks a user will produce? Is there ever a finite limit to the number of keystrokes, to the number of mouse moves, to the number of window dragging, et cetera, et cetera, et cetera? In many respects, what we are doing with our user interface code is we are responding to that infinite stream of events. We are taking their click, we are taking their key press, and we are deciding what to do, and then we are going back into a loop, waiting to see what the next one is. And user interface toolkits like React and Flutter have said, you know what, maybe we actually want to think about this differently. Maybe we want to think about processing the UI as a result of this. And by the way, when you start down that path, you are now very much on the edge of fully fledged reactive programming. You learn some functional programming along the way. You learn some functional concepts, and you started to learn about how React, why it's wired up the way that it is, reactive extensions, Akka, etc., etc., etc. By the way, the newest kid on that particular block, Elm. Elm is a Haskell language designed for the browser that is specifically built around the idea that events are infinite streams, and you write code to respond to when an event comes through the stream. And when that event is done processing, we just wait for the next event, rather than assuming that there will never be any more. All this from taking a 10-minute diversion through Haskell. Learning new languages does have practical applications. You may not be able to use Haskell on your next project. That's fine. Nobody's saying you have to. But what learning a new language does, whether it's a spoken language or whether it's a computer language, it opens you to different possibilities, particularly if the language is of an entirely different genre than what you're used to. Believe it or not, Java has benefited more from the introduction of C# than anybody in the Java community would ever have guessed. Because C# introduced a number of concepts into a language that was literally derived from Java. And Java developers eventually came over, took a look, and said, you know, that doesn't suck. The notion of properties that are captured in metadata so that I don't have to write getter and setter methods or ask the IDE to vomit, right? Vomit? Isn't that what the word? Vomit them up at you, right? If the IDE can write the code for you, kind of makes you wonder what your role is. C#, right? Public string name, curly brace, get, semicolon, set, semicolon, boom. I now have the properties, I have the storage, everything behaves exactly as it should. That's not a terrible thing. C# introduced delegates as a part of C# 1.0, which then got us to anonymous delegates in 2.0, which then got us to lambdas in 3.0. Not terrible. So what do we do? How do you engage in this polytechnical careering thing? Well, for starters, congratulations, you're already doing it. You're here. You toughed it out for 2 days, and when it would have been easy to say, you know what, I'm going to get home before traffic gets bad. Oh, it's raining outside. I don't want to get wet. You could have bailed. You stuck around. You're here. Congratulations. You're already on the first step. Because being at a conference, surrounding yourself with other people like you who are looking to expand their minds means you are already down that first step. You are continuing your self-education. Now, maybe your company paid for you to be here. Maybe this is coming out of your pocket. I don't know. I don't care. Because you could have just as easily taken your company's money and decided to go see Godzilla instead. Venkat will say you're seeing Godzilla now because we're just that good of friends. You're here. You're learning as people get up to leave. That's just ironic. But the other thing you need to do is you need to file this away inside your head. You need to create a personal ontology, a collection, an organization scheme. Where does Haskell fit in the world from your perspective? Where does TypeScript fit in the world? Where does JavaScript? Where does Elixir? Where does F#, Scala, Clojure? Where do they all fit? What are they? You need to be able to come up with a nice, succinct way of thinking about each of these technologies. What's the big deal about MongoDB, and why is it in any way different from CouchDB? And how is that different from InfluxDB or, there's so many different of these DBs. Of course, I'm blanking on all of them. How about the various cloud storage implementations, Dynamo and so forth? Where do they fit in the world of storage? How is the JVM different from the CLR, different from the V8 engine that powers Node, different from Python, Ruby, Lua, etc.? Where do they fit in your world? What's the picture? What's the landscape? What's the ontology look like? You need to figure this out for yourself. Now, in some cases, what this means is I'm just going to sit down, I'm going to read a book, and boom, it makes itself very, very clear. In other cases, you're going to have to spend a little time with it before it really begins to come home. The other thing is, if you know C# and you go learn Java, yeah, you're not really doing yourself any favors. I mean, yeah, there are definitely some differences in terms of how the Java ecosystem looks at the world versus how the .NET ecosystem looks at the world. But let me be very, very clear. C# and Java are evil twin brothers. They were born of the same idea. Let's make a simpler C++. And they're basically both fighting over primogeniture. Who will inherit the kingdom when the king dies? The king, of course, is COBOL. They are almost the same. If you're going to go learn something really, really different. Sit down and learn Haskell. Or an earlier ancestor to Haskell is ML. ML is a functional language, a purely functional language, and it actually is the ancestor to OCaml, the objective camel language, which was the predecessor to F#. If you're a .NETer, you know what F# is. Go learn something different. If you know a relational database, don't go learn another one. It's all SQL 92, mostly. Go learn a JSON store. Go learn a graph store. Go learn a key value store. Go learn something different. But it's hard. Let me just sit down and read through literally thousands of pages of documentation, said no one ever. How do I pick up this stuff? I'll give you an example. Currently, I'm in the midst of wrestling with Flutter. For those of you who don't know, Flutter is Google's recent native mobile toolkit for developing applications for both iOS and Android. As a matter of fact, at Google I/O a couple of weeks ago, they announced that Flutter was coming to the web and to desktop, but that's still very, very much an alpha. So I wanted to learn Flutter, and Flutter comes with another language called Dart. Well, let me tell you, Dart is basically object-oriented, meets JavaScript. Like so many other languages, Dart is not really all that interesting. But Flutter is definitely a different creature because it definitely takes a functional approach to building UI. It says that a user interface is the result of applying state through a function that builds the user interface controls. That takes a little while to wrap your head around. By the way, React does the same. So if you learn one, you're learning the other, conceptually at least. So I said, I want to figure out how to do Flutter. What do I do? Well, it turns out that in my family, we like to play cards. Specifically, hearts and spades. You don't have to know what the games are. You just have to know that in my family, we get very, very competitive. And normally, I'm the one who scores because I usually have a notebook on me, so it's easy for me to pull out paper and draw some columns, and let's start keeping track of scores. And my children have discovered that Dad makes mistakes, which somehow always end up benefiting him. It's the strangest thing. So recently they've taken to trying to check my work to make sure that, Dad's not accidentally cheating, because it's totally not intentional. I really hope they're not watching this video right now. So I'm building an app to score a game of hearts. It's a very simple app. It's very straightforward in a lot of ways. I mean, there's some interesting business logic because if one person takes all the hearts, then they've shot the moon and everybody else takes 26 points, whereas you stay the same. And there's some odd rules about the Jack of Diamonds will let people subtract 10 from their score. And if you hit the threshold, so if normally you play to 100 points, if you get to 100 exactly, your score resets to 0. Those are some really odd business rules that complicate the picture, but it's still a very easy program to build conceptually. And right now I am wrestling with how to do the UI to get this table of these 4 columns that represent the hands. It's not exactly a grid, so I have to build something custom. And when I'm done, I'm going to know Flutter a hell of a lot better than if I just sat down and read the documentation. I call this an evaluation function. You need your own. I mean, don't get me wrong. I have no copyright on a heart scorer. If you want to build one, that's cool. Just shoot me a link to the Play Store or to the Apple App Store so that I can see and judge your work and decide whether it's better or not than mine. The point of an evaluation function is to force you to use this thing. So for example, if at some point down the road I actually want to have a leaderboard stored up on the cloud somewhere, how do I get Flutter to make HTTP API calls back and forth between my server-side API and my client-side mobile app? And what do I do in those times when we are actually offline, like if we're playing cards on an airplane? Well, then I can't always check the leaderboard, but I don't want to lose those scores, so I have to figure out how to do some form of local storage, et cetera, et cetera, et cetera. You need your own evaluation function. Build an app. Doesn't have to be big, doesn't have to be fancy. You don't even have to complete it. It's a tool designed to let you experiment with the technology. Because once you get to a point where you feel like, I got this, I understand what this thing does, you've achieved your goal. Literally. The whole point of an evaluation function is not to produce the app, but to produce all the pain that comes with learning something. So once you get to the point where you know it, for whatever definition of know you're comfortable with, stop. Nobody's holding a sword over your head saying you need to ship that app. This is not work. You don't need to ship for this to be effective. Now, you may want to explore a whole bunch of additional options. That's fine. Go for it. It's your evaluation function. All of this, you sitting in the seats probably could figure out on your own. But what if you're the manager? What if you run the team? How exactly do you build a culture within your team that encourages this kind of learning? For starters, understand that what you want is a T-shaped team. Recruiters will frequently talk about the different shapes that individuals have. The I-shaped individual is somebody who can go really, really deep on one thing. The people who work, for example, on the Java virtual machine are generally pretty I-shaped people. They understand virtual machines, they understand garbage collection, JIT compilation, they dream in assembly language. They're very vertical. But you take them out of Oracle and ask them to go build a line of business app, and they're lost. No offense to them, they're very brilliant people. They could learn if they needed to. They don't, because they work in a very, very niche space. That's great if you want to be one of those and if you can get a sweetheart job at Oracle. I cannot, for a variety of reasons. Mostly that I don't want to make Larry Ellison more money. How many fighter jets does that man really need? I mean, seriously. You want to be a T-shaped individual. You've got some breadth. You don't want to be an underscore-shaped individual where you know lots about very little, or very little about lots, depending on how you want to look at that. You want to be a T-shaped individual who has some breadth. You've spent some time studying some languages, you spent some time studying some platforms and some storages, but you also have some depth. I really understand TypeScript and I really understand React because that's what we used on this particular project. And so I went deeper than just, can I do a evaluation function on that technology? As a manager, you want those people. You want those T-shaped individuals because they will be able to respond to whatever changing conditions come up. So you make education a formal part of what they do. If you're the manager of the team, easiest thing in the world, start a book club. Buy everybody on the team a copy of a book. Team I was just running at Smartsheet, we hired a whole bunch of junior developers, and they were going to be working in TypeScript and React, and many of them had done some basic JavaScript before, but didn't really understand classes or any of that stuff. So we all bought copies of Venkat's Rediscovering JavaScript. And every week, we went next door to the pizza place, and we sat down and we said, okay, let's read through chapter 1, let's read through chapter 2, right? And let's talk about what we find there. Let's talk about What concepts is Venkat bringing up? What concepts do the rest of the team not quite understand? Where did this come from? Why is this the syntax, et cetera, et cetera, et cetera? We did that for about 2 months. Not surprisingly, by the end of that 2-month period, the team's productivity went from here to about here. And sure enough, they shipped in 4 months an application that the CEO not only called out on stage during our user conference as the most exciting product that the company had shipped, but actually internally held that team up as the gold standard that he wanted all of engineering to approach. Doesn't take much. It really doesn't. You need to make sure that you are creating an environment where people can learn. And part of the way you do that is by getting people to disagree. I made it very clear to my teams when I was running them that I wanted somebody, for any particular discussion, I wanted somebody to disagree with me. Because there's this really fascinating concept called groupthink. You've seen it if you've ever played planning poker. You're sitting around a table with 7 or so people, and you say, how long will this feature take? And everybody puts their cards down. 2, 3, 2, 3, 2, 13. And all of you go, 13? And almost without question, the person who put 13 down immediately tries to roll back this transaction. No, hang on. Maybe I'm overthinking it. Let's vote again. Let's vote again. Because if I can just erase the fact that I voted 13 when the rest of you did 2 and 3, I won't look like the odd man out. I won't look like the weirdo. We are biologically wired to follow the herd. And when we find ourselves completely separated from the herd, it feels weird. We're not quite sure what to do. Fear reaction kicks in unless you deliberately encourage people on the team to disagree with you. In English, we have this phrase called the devil's advocate. This is the person who is literally, in ecclesiastical courts, is literally obligated with the job of arguing for the devil, arguing the dissenting case. In the Supreme Court of the United States, not only does the prevailing opinion get to write a judgment, why did they vote this way on this particular case, but the dissent as well writes a paper. This is why we think this is the wrong decision. Dissent is critical to building a group of people that will be actually able to think clearly. Because here's the thing, nobody in this room wants to disagree with me right now because they are afraid that it's only them. And the fact of the matter is, you're probably not alone, but nobody will know it until one of you says otherwise. It's okay for dissent. The worst thing a company can do is require consensus before a decision is made, because you know what happens then? Biggest asshole wins. If you're sitting in a room and we all have to reach unanimous consensus before we move, then the person who absolutely is the biggest jerk will say, I'm not voting with you guys until I get what I want. And we can sit here all day long. I've got no other meetings. What's on your plate? Not the way to run a business. If you're the manager, you need to set some non-business technical goals. What do we need to accomplish? How do we accomplish this? What are the approaches we seek to take? Let's go find some new answers. Let's create some projects where, hey, maybe we fail. As a matter of fact, one of the things that I've come to realize is if you really want people to grow, don't give them a project that they know they can deliver. Give them a project where they're probably going to deliver. Like 70% chance that they'll actually finish this, that they'll actually deliver this. Because 3 times in 10, they won't. And that's okay. Failure is okay. This is the biggest crime that the Western world has ever inflicted upon employees. This notion that failure is to be avoided at all costs, because, surprise, the only time you fail is when you try something you've never done before. Well, that is by definition innovation. Everybody's out there talking about innovation and how wonderful it is. If you never try anything new, you will never innovate. And if you never innovate, of course, you'll never fail, but you'll never innovate. The other thing that you need to do as a manager is figure out what your company actually does for a living. How do you make money? What is the core business model, so that you can take the various things that people work on, evaluate it, and decide how it applies to your business. Because otherwise, you're just basically engaging in, well, for lack of a better phrase, mental masturbation. Probably the most critical thing, though, is to understand that not all of your developers are cut from the same mold. We're different. We're all of us different. People have different experiences. People have different backgrounds. People have different perceptions. We're all different somehow. Encourage that. Embrace that. That dissent I mentioned earlier, that's a good way to make sure that you do that. Venkat looks at the world very different than I do. He's got a background in electrical engineering. My background is in international relations. Go on, ask me, why do nations go to war? I've got a whole 20-page finals answer framed on my wall at home because it was like the culmination of everything I was studying in international relations. You want to talk philosophy, economics? You want to talk psychology? Yeah, let's go. You want me to do big O notation? Go talk to him. Different backgrounds. It's part of the reason why Venkat and I get along so well, is we each bring very different things to the table when we start talking about presentations and so forth. And this is true for a variety of different folks. It's part of the reason why I enjoy traveling, because I get to see different perspectives all the time. This is not easy. I'm not going to stand up here and shine your ass for a little bit and say, oh yeah, you guys are amazing, you can do this. This takes work. This takes a ton of work. It is not a thing you're going to be able to accomplish in the next 365 days. But I absolutely guarantee you that if you walk out of here and you think about something that you saw here and you say, I'm going to go spend a little bit more time. I'm going to create an evaluation function. I want to go build a website using Elixir, and I'm going to have that website do whatever, heart scoring, or I want it to be a very simple CRUD database or what have you. I don't care. Evaluation function is yours. I'm going to go work on that for the next year. When you come back next year, you will understand far more about Elixir than anybody else around you. And sure, maybe it's not the right tool for your company right now, but one day you're going to be standing in the elevator with the vice president of technology, and he's going to say, man, I wish it were easier to build these reactive applications. And you can say, you know, boss, I was playing around with this thing called Elixir. And the boss is going to go, really? Tell me more. And that's when it will pay off. I want to thank you guys for bringing me here to Riga, specifically Dimitri and Andre for putting up with me. You guys have fun.